last lecture, what we have seen in the last lecture, we have seen about the BGP, how to configure iBGP neighborship. We have seen how to configure full mesh neighborship, and we have seen how to configure iBGP neighborship with loopbacks. Correct. Now we have authentication also. We can configure authentication also in BGP. Okay. We can configure authentication also in BGP. How to configure authentication? So the command to configure authentication, like we have in other routing protocols, we have authentication. Okay, so BGP border gateway protocol supports authentication mechanism using MD5. Okay, MD5 algorithm. Now, when authentication is enabled, uh, any TCP segment belonging to BGP, any TCP segment belonging to BGP exchanged between the peers is verified. Okay, they will verify the TCP segment and accept only if authentication is successful. Okay, now to configure authentication, for authentication to be successful, both the peers must be configured with the same password. Now, if authentication fails, the neighbor relationship is not established. Understood? So, to configure authentication in BGP, let us see how to configure authentication in BGP. Okay, these are the routers. Now, what we will do first, we will configure the all the routers using BGP. Okay, and I'll do whatever we have done till now. What we'll do, we'll configure all the routers in BGP, and we'll configure the routers with loopback, the neighbors with loopback addresses. Okay, router BGP 500. I'll say neighbor 12.0.0.1, neighbor 12.0.0.1, remote ASS 500. Then I have neighbor 13.0.1 and 14.0.1. These are my neighbors. Okay, I'll advertise network, the LAN network I'll advertise, no auto summary, no synchronization. Now WAN interface, not preferably to we can exclude the to advertise the WAN interfaces. Okay, so it makes your BGP or routing table more big. Okay, it will make your BGP or routing table more big, so you can just avoid to advertise it, because your neighborship is formed with the help of loopback addresses. So router BGP 500, neighbor 11.0.0.1, remote ASS 500, then 13 dot and 14 dot. Network 20 dot network, no auto summary, no synchronization.
You don't need to advertise your loopbacks either.
No, I don't need to advertise the loopback over here. That's what I'm doing. See, that day we advertise the loopback, okay, and then we advertise the loopback again in IGP. So I don't need to advertise loopback in both the routing protocols. Okay, I can just advertise
Right.
my loopback in my IGP so that they can give me the things. Understood?
I do. I understand. Thank you.
Now router BGP 500 neighbor on man R3 11.0.0.1 remote AS is 500 neighbor 12 dot and 14 dot network 30 dot network, no auto summary, no synchronization. Router BGP 500 neighbor 12.0.0.1 remote AS 500 neighbor 13 dot and 11 dot. I have given the neighbor commands. Network command 40.0.0.0, no auto summary, no synchronization.
What is the synchronization?
I'll explain you, don't worry.
Okay.
Now if I go in R1 and if I see show IP BGP summary, I can see my neighbors, but all the neighbors are having the state as active. Now what we have to do to resolve the active state, we have to check the connectivity for the neighbor. So I'm not able to ping my neighbor. So first step is you have to make sure that there is connectivity to the neighbor. So there is no connectivity. So how I can make the connectivity? If I see the routing table, I'm not having any route of 12 dot network. Of my neighbor, I'm not having any route. So no entry of this, the neighbor address is found. That is neither the 12 dot, neither 13 dot, neither the 14 dot. So what you can do, the router R1 don't know how to reach the neighbor address, correct? So to learn about those neighbors, BGP relies on IGP protocol, as I told you. So here is the issue is with routing. So to fix, we have seen that day we have to configure routing protocol. So what I'll do, that day we have configured OSPF. Today we can see just EIGRP. I will advertise all my networks, network 1 dot network and 11 dot network. No auto summary. Router EIGRP 100 network 20 dot network 2 dot network 1 dot network and 12 dot network. No auto summary. Router EIGRP 100 network 30 dot network 3 dot network 2 dot network and 13 dot network. No auto summary. This thing we have seen in the last lecture. I'm just revising the thing quickly. Okay. Router BGP 500 network 40 dot network 4 dot network 3 dot network and 14 dot network.
Shouldn't that been EIGRP?
Sorry.
You did BGP. I thought that was supposed to be EIGRP on router 4.
Okay. network 30 dot network 3 dot network. Sorry, again I've made a mistake. Here it will be 40 dot network, not 30 dot network. 3 dot network is fine. Then 4 dot network and 14 dot network. Okay. On R1, I have not advertised the 4 dot network. That is the reason it is not forming the neighborship. See now all the I've configured all the neighborship within the this thing. Now let me check. Still the state is active. Let me try to ping. Now I'm able to reach my neighbor, but I'm not able to form the neighborship in BGP with that neighbor. So the second step is the other issue can be that problem with the source address. I explained you the source address. Now here the source address that it is going with is it is taking the source address as 1.1.1.1, and when this 1.1.1.1 is going to R2, R2 is seeing its neighbor command. R2 is seeing its neighbor command, and the neighbor command is given with this address, with this loopback address 11.0.0.1. So R2 will reject that open message. Okay, it will not reply with that open message. So what you have to do, you have to change the source address, update the source address for all the neighbors. So I have to say router BGP 500, and I'll say neighbor 12.0.0.1 update source loopback 0, 13.14 dot. Router BGP 500. See, the neighborship is up. Neighbor 11.0.0.1 update source loopback 0. Neighbor 13 dot and 14 dot. Router BGP 500 neighbor 11.0.0.1 update source loopback 0, 12 dot and 14 dot on R3. On R4 neighbor, sorry, router BGP 500 neighbor 11.0.0.1 update source loopback 0. Neighbor 12.0.0.1 and 13.0.0.1. Now if I go on R1 and if I check show IP BGP summary, you can see my neighborship is up now. My neighborship is up. You can see I am getting a numbers, I am getting some prefix. I can verify show IP BGP summary on all the routers. Show IP BGP summary. Show IP BGP summary. Okay, understood. If I see show IP route OSPF, I can see the OSPF routes also. Sorry,
Yes,
EIGRP.
sir.
EIGRP routes also over here. I am getting all the routes in EIGRP. Okay, so this is how you can configure the things with the loopback addresses. Now, authentication. Now you have to make sure authentication is established between all the peers, and that they should use password as Cisco 123, you can say. Okay, now the peering should establish only if both the routers runs BGP version 4. Okay, so I have to make sure that both the all the routers are running BGP version 4, and I have to configure authentication. So to configure authentication, you have to go in the BGP mode, in the router mode. You have to say neighbor 12.0.0.1, and here you have to say password Cisco 123. And for 14 dot. Now I also told you that the peering should establish only if all the routers are running BGP version 4. So I'll say neighbor 12.0.0.1 version 4, neighbor 13.0.0.1 version 4, neighbor 14.0.0.1 version 4.
So you could run a different version per neighbor if you wanted.
I am saying that you are my neighbor and you should also run version 4. See now what I'm getting, bad authentication. Bad authentication. Why? Because I have not advertised, I have not configured it, the things on other routers. Okay, so do show history. This is my history command. So what I'll do, I'll copy these all things, notepad, I'll paste it over here, and I'll just change the things. For R2, I need over here 11 dot network. Correct? Paste. For R3, I need 11 dot network. For R4, I need 11 dot network. Got it? So what I can do, I can just copy these commands and I can paste on all the routers in the BGP mode. Okay. Now I've configured the authentication and all the routers are running BGP version 4. See, my neighborship is up. See here I'm having the neighborship. See, my neighborship is up with all the routers on R3 as well, on R4. All the routers on R1. See, my neighborship is up. And we have configured the neighborship with the help of authentication. We have seen what? Authentication. Okay. Now, you will say me why we use BGP. Why we use BGP? BGP is very complicated. BGP is very complicated. Till now, whatever you have seen, we have to give For one thing, we have to give one command. For each single thing, I have to give one command. So why we use BGP? What is the use of? Just we need to communicate between the two autonomous systems. We use BGP. But why we are using BGP over here in with iBGP neighbors? We have to give multiple commands over here. For each thing, we have to give multiple commands. Now, there is something that will reduce your commands, that is known as peer groups. Peer groups. Peer groups are something that will reduce your command. How it will reduce your command? It will make a group. Okay, just let me open the document. Peer group. Okay, what peer group will do? Apply same policies to multiple neighbors. Useful when many neighbors have the same policies. When many neighbors have the same policies, configuration is simplified and updates are generated once per peer group. Now, how we will do? See, what all things we done common in all the neighbors? What all things, if I see show run pipe section BGP, what all things are common over here? For all the neighbors, we have given the same command. See, if I see for 12 dot, I have given the remote ASS 500. For 13 dot also I have given the remote ASS 500. For 14 dot also I have given the remote ASS 500. Correct? If I see the password is same, the update source is also same, the loopback version, the update source loopback number is also same, and the BGP version is also same. So what we are doing over here, we are configuring differently for each neighbor. But with the help of peer group, what we can do, we can make a group and we can configure those like we used to do in access list. We used to call the access list on the interface. Okay, in the in direction on out direction. Here also we can create the peer group, and whenever we are advertising the neighbor, we can just use the peer group what we have made. So how we can do the things, we will see practically. You will understand what I'm trying to say. So I removed all the configuration whatever we have done. Okay, so let us see peer group configuration now. Peering, whatever we have configured till now, we will see the same configuration with peer groups. Now, first of all, what I will do, I'll advertise all the router in EIGRP, router EIGRP 100, network 10 dot network, 1 dot network, because peer group can be only done in BGP commands. Okay, and 11 dot network, no auto summary. Router EIGRP 100, network 20 dot network, 2 dot network, 1 dot network, and 12 dot network, no auto summary. Network 30 dot network, 3 dot network, 13 dot network, and 2 dot network. router EIGRP 100 network 40 dot network 4 dot network 14 dot network and 3 dot network. Okay. Now after advertising these all things, what we will do, we will create a peer group. We will create a peer group. So what we will say, router BGP 500 for neighbor, for all the neighbor, the peer group is the, so suppose neighbor, and here if I give question mark, it is asking me a neighbor tag. So I'll use a tag as CCNP. And what it is? It is a peer group. CCNP, it is a peer group. Okay. So this will enable the peer group. Now for all the neighbors, my remote AS number is same. If I'm advertising any neighbor on any router, my remote AS is same. Correct? My remote AS will be same. So what I will do, I will say for any neighbor in CCNP, the remote AS will be 500. For my neighbors, the update source will be loopback 0 only for all the neighbors. For all the neighbors, the BGP version will be 4. For all the neighbors, the password will be CCNP password will be Cisco 123. That's it. Now I'll advertise my this. I'll advertise my WAN interface. No auto summary, no synchronization. Do show history. Now these will be the same command on all the routers. Okay, these will be the same command on all the routers, because before giving this, what I'll do, I'll advertise my neighbors. Now how to advertise your neighbor? Previously we were giving remote AS for all the neighbors. Now here what I will do, I will say neighbor 12.0.0.1 use the peer group CCNP and take the configuration. That's it. Understood? Do show history.
That's a lot more convenient.
Sorry?
I said that's a lot more convenient.
Yes, it is more convenient now. So whatever the similar commands are there, the neighbor command, whatever the neighbor command you are giving, similar neighbor commands for all the neighbors, you can use the peer groups. You can use the peer groups. Now I'll go over here and what I'll do, I'll paste the command over here. That's it. Now I'll advertise network 20.network. No auto summary, no synchronization. Neighbor 11.0.0.1 use the peer group CCNP. Got it? That's it. Here also I'll paste the command. Advertise the network 30.network. No auto summary, no synchronization. Neighbor 11.0.0.1 use the peer group CCNP. Sorry. 12 dot and 14 dot. Isn't it easy now?
Much easier.
So BGP is very easy to configure with the peer groups, becomes very easy to configure with the help of peer groups. 11.0.0.1 neighbor, sorry, peer group CCNP, neighbor 12.0.0.1 peer group CCNP. Show IP BGP summary. My neighborship is up with all the routers 12.13.14. Show IP BGP summary. My neighborship is up. Show IP BGP summary. Neighborship is up. Show IP BGP summary. Got it? So this is what my, see here you can get the BGP version 4, AS number 500. Okay, message receives and message sent. Understood? So see what I've done, whatever we have studied till now in the last lecture and in the today's lecture, I have configured that all thing in just 5 minutes. Correct? With the help of peer group, you can quickly configure all the commands.
Right.
Any doubt?
It seems pretty straightforward. Same commands for the most part, just in the peer group.
Yeah. So if I see over here, show run pipe section BGP. See what all commands I gave over here. I advertised my network. I created a peer group. Okay, I said this peer, I said in this peer group for my neighbor, the remote AS should be 500 for all the neighbors. CCNP peer group, the password should be, for the authentication password should be Cisco 123. Update source loopback should be loopback 0, version should be 4, because all the things were common for all the neighbors, right? So what I did, I just used the peer group, and instead of writing three commands, like instead of writing these 3 commands for each neighbor, for each thing, like for authentication I have to write 3 commands, for version I have to write 3 commands, then for remote AS I have to write 3 commands. What I did, I just only wrote one command over here. Understood?
Yes.
Any questions?
No, I'm good on peer group and the BGP right now.
Okay.
So, Qayyum, finally, the objective is to save the number of commands, right? Here, and that saves time.
Reduce the number of commands, reduce the configurations.
Okay, okay, okay. Thank
Okay.
you.
If you want to see, while I was configuring the full commands in different ways, okay, it means I was configuring for each neighbor, I was giving different commands, so it was looking very complex, correct? And you also might have thought that what is this, BGP is so complicated, we have to give so many commands. Okay, but it is not. BGP is very simple with the peer group things. Understood?
Mhm.
Now we have seen the full mesh neighborship. What is the advantage of full mesh neighborship? Disadvantages, sorry, not advantages. Advantages we have already seen. So disadvantages: administration, configuration management on increasingly large number of routers. Okay, So if you are having suppose 20 routers, then you have to give 19 neighbor commands. Correct? You have to give 19 neighbor commands to be neighbor for each router. Understood? So administration is the first disadvantage. Then number of TCP sessions. So like total number of TCP sessions will be n into n minus 1 divided by 2. So if you are having suppose 20 routers, then you are forming 19 neighborship. Okay, so you will be having 19 TCP sessions. Okay, if maintaining those sessions, maintaining those TCP, see one neighbor, for one neighbor you will be having one TCP session. Okay, so maintaining this TCP session will give you overhead, processing overhead, so you will get extra overhead. Okay, so this is the disadvantage will full mesh neighborship. A number of higher neighbors generally translate to number of paths for each route. Memory consumption is there. Understood? The memory consumption is there. So we have seen there were two solutions. First was solution for BGP split horizon. We were having first was what was split horizon? An update sent by one IBGP neighbor should not be sent back to another IBGP neighbor. Okay, prevents routing loop within the same autonomous system. So there were two solutions. First was full mesh neighborship. Every router should be neighbor of every other router within the autonomous system. Okay, so these are the scalability concerns of my or disadvantages of my full mesh neighborship. Okay, BGP table size will increase, the number of TCP sessions will increase, administration will increase. Okay, now the other solution is route reflector. Route reflector. Now it is a scalable alternative to an IBGP full mesh. How it is a scalable alternative? Now what we will have over here, we will have one, suppose if I show you over here, suppose what we will do, suppose we are having some routers in this way. Okay, so okay, what we will do over here, we will suppose these are the routers and they are connected with each other. Now this is, as I told you, scalable alternative to IBGP full mesh. Now what I will do over here in route reflector, we will make one router as server and other will be clients. Other will be clients. Others will be client over here. Now what will happen? The client will only update the server. Client update the server. Okay, server updates to all the remaining clients. There is no split horizon rule applies on RR server. Okay, so what will happen over here? The client, the clients will only update the server. The client will, it provides the scalable alternative. Okay, so client updates the server, server will update all the remaining clients. Now all clients should only establish neighborship with only the server. Okay, clients will not establish neighborship with any other neighbor. Oh, sorry, any other client, you can say. In case, so in some case you can also have two servers. Okay, server will establish neighborship with each other. Server and clients will have the neighborship. Understood? Server and the client will only form the neighborship with server. That's it. The client to client neighborship will be not there. Client to client neighborship will be not there. Only client to server neighborship will be there. And you can have two servers also. Now server, both the servers will be having neighborship, and all the clients will also have the neighborship with both the server. Understood? This is my route reflector. Route reflector.
Can you
Okay.
only have two servers? Is there a max server? Is there a primary server?
Yes. So why we have two server? This is my primary server, and if this server fail, there will be a single point failure. So that is the reason we keep, for redundancy, we keep two servers. Understood?
Yes.
Getting me?
Yes. I understand.
So now, now we will configure iBGP as the same autonomous system 500. Okay. And I'll make sure that all the routers should be able to see the routes from other routers in the routing table, okay, through BGP, and do not use full mesh. I'll not use full mesh peering. Okay, I'll use route reflector over here. So what I'll do, I'll just remove all the configuration. I'll just stop the routers and start the routers again. Just a second. Now router BGP 500, I'll form the neighborship 1.1.1.2, remote AS is 500. Okay, network 10.0.0.0 network 1.0.0.0, no auto summary, no synchronization. Okay. Now on router 2, router BGP 500 neighbor. So what we will do over here, we will only take R1, R2 and R3 first. Okay, we will only take R1, R2 and R3. Okay, so now my plan is I'll make R2 and R2 as my server, and R1 and R3 will be my clients. R1 and R3 will be my clients, and R2 will be my server. Understood?
Yes.
Neighbor 1.1.1.1, remote AS is 500. Neighbor. Now what I told you, all the clients will be having the neighborship with only server. So what I did on R1, I only gave the neighborship with 1.1.1.2, that is my server. Okay, network 20.0.0.0, 2.network and 1.network. No auto summary, no synchronization. Now R3 is also my client. R3 is also my client. So what I'll do, neighbor 2.2.2.1, remote AS is 500. Network 30.network, 2.network. No auto summary, no synchronization. Okay. Now verify it on R2. Show IP, BGP summary. You can see the neighborship with 1.1.1.1 and 2.2.2.2. Okay, the neighborship is up. If I see show IP BGP, this is my BGP table. I am forming the neighborship show IP BGP. Okay, if I go on the R1, if I see show IP BGP, here I am getting the 10.network and my 20.network. Here I am not getting the 30.network. On R1, and if I see on R3, show IP BGP. On R3, I will not get the 10.network. So R1 and R3 cannot see each other routes in their respective BGP table because of split horizon rule. So in order to get the routes to be learned, we have to we have two solutions. Okay, full mesh we have already seen. Route reflector. Now to configure route reflector, all clients should establish neighbor with only server. Okay, clients will not establish neighbor with any other client. So if in case sometimes you might have two servers. Okay, so now we are only having one server. Okay, so now we are only having one server.
How
So
are
now,
you able to tell the server? Like, is there a
yeah, I'm just telling right now.
okay?
I have not configured yet that thing. The server thing I have not configured yet. So I'll be just configuring right now. So what I'll do, I'll go on R2, whichever router you want to make it as server. You have to go on that router. You have to go on that router and you have to go on the router BGP 500 and you have to say neighbor 1.1.1.1 and here you have to say this neighbor is my route reflector client. This is the route reflector client and the other neighbor is 2.2.2.2 route reflector client. Got it? Now you can see the neighborship came up. Okay. Now if you go on R1 and if you check show IP BGP, you can see the 30 dot network. You can see the 30 dot network. If I go on R3, I'll be able to see the 10 dot network over here. Understood?
Yes.
This is my route reflector. This is my route reflector. Now you can do route reflector with the help of loopback addresses also. You can do route reflector with the help of loopback addresses also. Now we have done with the help of what? With physical interface. You can do it with the help of loopback interface also. Router BGP 500. You can say no. 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 On R4 it was not there. We haven't configured anything. Okay, now to configure, see, I will take the long path. Why I'm taking the long thing means I will configure each for, I will not use the peer group. Okay, because if I'll configure again and again, the commands will be going in your mind. Okay, so what I will do, I'll configure for each neighbor, I'll configure each command differently. I'll not use the peer group over here. So router BGP 500 neighbor 12.0.0.1 remote AS is 500. So as I told you, all the clients, my R1 and R3 are clients. So all the clients will only have the neighborship with server. Okay. And I'll say neighbor 12.0.0.1 update source as loopback 0. I'll advertise my LAN 10.0.0.0, no auto summary, no synchronization. Router BGP 500, neighbor 11.0.0.1, remote ASS 500, then update source as loopback 0. Thirteen dot, as I am making R2 as my server, okay, R3 router BGP 500, neighbor 12.0.0.1, remote ASS 500, then neighbor 12.0.0.1, update source is loopback 0. Network 30.network, no auto summary, no synchronization. Show IP BGP summary 11 dot and 13 dot. Okay. R1 show IP BGP. No, I am not getting the 20 dot network. Okay, I got it. We haven't configured the IGP protocol. When we are using the loopback, we need to configure the IGP protocol.
Should R1 be advertising the 20 dot network?
Sorry, on R1 I don't need 20 dot, I need 10 dot.
You're not an EIGR.
router EIGRP 100 network 30 dot network 2 dot network 13 dot network. I am getting 10 dot network and 20 dot network as my iBGP neighbor. Okay, as my iBGP neighbor, but I am not getting the 30 dot network over here. I am not getting the 30 dot network over here. So R3 do not have R1 routes, that is 10 dot network. R3 will not have the R1's route, show IP BGP. If I see over here, R1's route, that is my 10 dot network, and R1 will not have R3's route, that is my 30 dot network, because of the split horizon rule. So I have to configure here the route reflector. Neighbor 11.0.0.1 is the route reflector client, and 13 dot is also my route reflector client. Got it? I got the 30 dot network over here. Okay, I got the 30 dot network over here. You can see on R3, if I go show IP BGP, show IP BGP, 10 dot network is there. Understood route reflector?
Yes.
Any questions?
No, you did mention something about the server and a secondary server.
Yeah, we'll go over there.
Okay.
Yeah. So Qayyum, actually, my question was how route reflector is different from peer group. Actually, it's for the same purpose, right?
Peer group is something different.
Peer group is for saving the configuration task,
Yes.
or and route reflector.
Route reflector
I
and
mean,
full mesh is for split horizon.
uh, I could not get that point actually. So if you do full mesh, okay, using peer group, that will save my time. But how? Why we are going for route reflector?
See, there were disadvantages in full mesh.
Okay.
These were the disadvantages of full mesh. Administration, because if we were doing full mesh, suppose if we are having 20 routers. See, what is full mesh? Exactly what is full mesh? If this is the scenario, then in full mesh, I have to give a neighbor command for this router, for this router, for this router, and for this router. So suppose if I am having 100 routers, so I have to give 99 neighbor commands. Administration work got increased. Understood?
Yeah.
You have seen in full mesh, we have to configure for each neighbor, we have to give one command. For each neighbor, we have to give one neighbor command. So if we are having 100 routers, then we have to give 99 neighbor commands. Administration work is being increased, configuring the configuring management to increasing large number of routers. Now TCP connection. Now whenever we are forming neighborship with one router, they form a TCP connection. Suppose these two are neighbor. Now they will form a TCP connection, one TCP connection. These two routers will form another TCP connection. These two routers will form another TCP connection. So suppose I am having 100 routers, then I will again form 99 TCP connections. 99 TCP connections. Okay, if I see on this router's perspective, okay, so I will form 99 TCP connections, which will create extra overhead to run these TCP connections. It will need more memory. Memory consumptions will be there, and the BGP table size will also increase because the neighbors will increase. We will have one command, one line for in the uh, neighbor in the BGP table. We will have one command for each neighbor. Okay, so this is something that these were some disadvantages of full mesh. That is the reason we use route reflector.
So
Now,
peer group is not used nowadays, or I mean, it is
see,
obsolete, or how
peer
is it?
group, why you're mixing peer group? Peer group is nothing. This peer group is not about anything full mesh or anything. Peer group is something different, Nilesh. Peer group is to just minimize the configuration. It is nothing to take the things about full mesh or route reflector. See, you're getting confused.
Okay.
When we started, we saw split horizon. We saw
Mm-hmm.
split horizon. What was split horizon? If suppose I am on R1, what does my split horizon rule says? If I am on R1, this is my network that is there in R1. Now, what I am saying,
Yes,
what
split
BGP,
horizon. That if any router is receiving a route, it cannot propagate the same route to its neighbors.
its neighbor. This was split horizon. So for split horizon, we were having two solutions, full mesh and route reflector. Got it?
Okay.
So
Mm-hmm.
full mesh was this, that we have to form neighborship with each neighbor. This, this, and this. This is full mesh. I have four routers. So on R1, I will form neighborship with R2, R3, and R4. If I would have 100 routers, then I would have formed neighborship with 99 routers. Correct?
Mm-hmm.
This is the disadvantage. 99 TCP connections, maintaining the 99 TCP connections will create extra overhead. Okay, and also my BGP table will be huge. Peer group is what? Peer group means, see, when we were giving these commands, for each neighbor, we were giving these commands. Also, we were giving this neighbor command, neighbor 13.0.0.0, sorry, 11.0.0.1. I was giving remote as 500. Now this command I was giving for all the neighbors. These commands were same, 13 dot on all the routers. Now see how many commands are there now. Also one more command was there, update source.
Okay.
Update source, loopback 0. So on a single router, I was giving these many commands till here. For my neighbors, I was giving these many commands on a single router. All the basic configuration using authentication, using version, using my remote AS. All these commands were given on the router, on each router. Got it?
Yeah.
So what we did, see, for all the routers, suppose this is R2. This
So
is my
maybe
R2's router configuration.
can we use peer group to configure route reflection?
Yes, we can use what I told you when I was starting the route reflector thing. What I told you that I am not using peer group here because I am showing you the commands. See, okay, when we will be configuring the things with the loopback addresses, okay, sorry, with the two routers, I'll show you that thing. Okay, with the two servers, when we will be configuring with the two servers, I'll show you the peer group thing. Okay, so what we did, peer group is something we used to have these many commands to reduce these many commands, because see, for neighbor 11 dot I have the same password, for 13 dot also I have same password, for 14 dot also I have same password, version is also same, remote AS is also same, source loopback is also same for all the neighbors. So what I did over here, I created a peer group. I created a peer group CCNP. And what I said in the peer group CCNP, I said for all the neighbor, what was the command for peer group? Robert,
Say it one more time. I'm sorry. You broke up on me.
what was
I
the command for peer group? To create a
Uh,
peer group,
yeah,
what was the
you're
command?
under the.
I have already created the peer group.
It's the
For
router, and then you give the descriptor name like CCNP.
Yeah.
CCNP, then I have to say remote AS is 500.
Yeah.
So what I'm saying, for all the neighbors, the remote AS will be 500. Then neighbor CCNP update source will be loopback 0. Neighbor CCNP version will be 4.
So these
BGP
are the
version
commands you are giving on route reflector router.
in the router mode.
Okay.
I am explaining you right now. I am not configuring anything.
Okay. Okay.
Okay. Now neighbor, what is one more command? Password. Password is Cisco 123. Now we will implement this thing when we are giving the neighbor command. Whenever we are advertising the neighbor, we will say neighbor 11.0.0.1. Now I will not use these password for these all things. I will just say go to the peer group. Go to the peer group CCNP. Copy, paste, 13, paste, 14. See now how I have minimized my configuration. Now I need to do only this configuration. Instead of writing each neighbor command and each things, I have to only write these commands. Understood? This is what peer group is. You can use peer group with full mesh, also with route reflector also. See, peer group is just forming the neighborship, IBGP neighborship. Peer group is nothing to do with full mesh or with route reflector. Understood, Nilesh?
I got the point, Qayyum. Yeah.
Now see, Robert was asking me about two servers. If we want to have two servers, how we can configure them? Okay, so we will see now here R2 will be my first server and R4 will be my second server. R2 will be my first server and R4 will be my second server. Okay, now I'll configure, I've already configured all the things. Okay, let us remove all the things. Let us remove. I'm keeping the EIGRP configuration. I'm just removing the BGP configuration. Okay, I'm removing the BG. I've removed the BGP configuration. Now, I still have the. I still what have? I still have the my EIGRP configuration. Show IP route EIGRP. See, still I'm having the EIGRP configuration. So what I'll do, I'll use the this R1 and R3 are my client. So I'll say router BGP 500. Okay, then I'll say you want me to create the peer group?
It doesn't matter to me.
It doesn't matter, right? So I can create the peer group. There is no issue. So what I'll do, I'll say neighbor CCNP is the name of the peer group. Okay, then I'll say for neighbor CCNP, the remote AS will be 500. For neighbor, the update source will be loopback 0. Okay, for neighbor CCNP, version will be 4. I'm not using the password authentication. Then what I told you, the clients will only form the neighborship with server. So R2 and R4 are my server. So I'll say neighbor 12.0.0.1 and use the peer group CCNP. Neighbor 14.0.0.1 use the peer group for this. Understood?
I had one question on that. If there's not a direct connection from R1 to R4, would it? Never mind. Never mind. I'm good.
Sorry, come again.
I answered my own question. Never mind.
Okay. Now I've configured R1. Let me go on R2. R2 is my, let me first configure both the clients. So router BGP 500, R3 is my client. Then neighbor CCNP peer group. So I can go over here, do show history, and I can copy this peer group command. Okay. Now here the neighbors will be Same 12.0.0.1 and use the peer group CCNP and 14.0.0.1. Now come on server. Now server router BGP 500 and here I will say neighbor CCNP peer group. Paste the command. Now server will have neighborship with all the clients and the server. Okay. .13 and 14. See how the configuration is getting simplified. Okay. Here you can give one more command. On the neighbor side, you can add one more command in the CCNP. You can say CCNP route reflector client. What you can add? You can add route reflector client. Okay. For all the neighbors, you can add route reflector client also. Okay. For all the neighbors, you will add this command also. Show run pipe section BGP. See, this is my peer group. These all are the commands for all the neighbors. I'm saying all the neighbors will be in remote AS 500. The update source will be loopback 0. Version will be 4. And all the other neighbors are my client. For this R2, all the others are client. R1, R3 and R4 are client. Okay. And on R4, also I have to do the same thing. Router BGP 500. And here I'll paste this command. Okay. Then neighbor. Now this is also a server, so it will also form the neighborship with all the routers, all the clients. Peer group CCNP. Sorry. I was doing on R3. I by mistakenly did it on R3. No router BGP 500. I have to remove the configuration. Router BGP 500 neighbor CCNP peer group neighbor CCNP remote AS will be 500, version will be 4 and update source will be loopback 0. Here my neighbor will be 12.0. Because this is my client. Use the peer group CCNP and 14. Router BGP 500 neighbor I also left one more thing. 10 dot. I haven't advertised the LAN interfaces. Now, if I see on R2, show IP BGP summary. Show IP BGP summary. There is some mistake in the R4's configuration. Show run pipe section BGP.
Is the EIGRP set up on router 4 too?
Yeah, correct. We are not running EIGRP over here because I was just using R1, R2, and R3 previously. Network 40 dot network, 4 dot network, 3 dot network, and 14 dot network. Why my neighborship is not coming? EIGRP is there. Router EIGRP 100, network 4 dot network. Auto summary. Router EIGRP 100, network 3 dot network. Show IP BGP or show IP BGP summary. Let me go on R2. Show IP BGP summary. I'm having three neighbors 11, 13, and 14. 11, 13, and 14. If I go on R4, show IP BGP summary, three neighbors, all are up. Okay. Now if I go on R1, I'll be having two neighbors, both the servers 12 dot and 14 dot, both the servers. I'm forming the neighborship with both the servers. Okay. If I see show IP BGP, the BGP table, I will get each and every route. I'm getting the 10 dot, I'm getting 20 dot, 30 dot, and 40 dot routes. I'm getting each and every routes. Understood? This is how you can configure. See what configuration I've done on the server. Show run pipe section BGP. What I've done on the server, I have added a command. This command for all my neighbor, all the neighbors will be the route reflector client on both the server. See, And who all are my neighbor? These are my neighbors. 11.12. And 13. All are route reflector client. Okay. Understood? Nothing to be done on the clients. On the clients, you have to just form the neighborship with the servers. That's it. Here I am having 2 servers, so I form the neighborship with 2 servers. So you have to just form the neighborship with 2 servers, and on the server you have to say the neighbors are the route reflector client. So the router will automatically come to know that I am the server. That is why I have been given the command as my neighbors are the clients. Got it?
Right. Is there anything specific that denotes one as a primary server and a secondary server?
No, there is nothing such as a primary server. We can keep
Okay.
anything.
They're
Okay.
just both in server mode.
Yes,
I
both
got
are
you.
the server. Both the servers will be updated.
I understand.
Okay. So here we complete our IBGP things. Okay. So from tomorrow we will start our eBGP, external BGP. Okay. External BGP, we will see two autonomous system, between two autonomous system, how to configure two autonomous system, and how the routes are exchanged between both the autonomous system. Okay. Understood?
Yes.
Okay, so we'll stop over here for today.
Okay. Thank you.
Thank you very much. Bye. Take care.